And today, I will continue to give the lecture in the real analysis. Yeah. And today, I will show you one theorem. And the theorem talk about the infimum. And after I have gave you one theorem about the supremum, I think this theorem is similar to that. Okay, let's see together. What is it? Yeah. Theorem 1.8. And what does it say about? If a set of real number here S is bounded below, below then the infimum, you can say infimum of S is the unique real number. The unique real number alpha, we call alpha, satisfy condition or the following condition. Condition A, x is greater than or equal to alpha for all x in S. Condition B, if epsilon is a positive number, no matter how small it is. Let's say no matter how small it is. If epsilon is greater than 0, no matter how small it is, there exists x0 in S, capital S, in S, such that x0 less than alpha plus epsilon. And I can remind you that the theorem is similar to the theorem 1.4. The theorem 1.4 that I have gave it to you, it's talk about the supremum, right? And this one, we talk about the infimum. So how to prove it? Let's see together. Proof. Yeah. I can say sin alpha is a sub sorry is an infimum. Yeah, is an infimum of S. Then alpha is alpha is a, you say, is a lower bound, right? Lower bound of S. Since alpha is an infimum of S, then you get alpha is a lower bound of S. Why? By the definitions of infimum. Infimum of any set is the lower bound that is the biggest one. An infimum of a set is the lower bound of that set, and that is the biggest one. So infimum you can get lower bound. Yeah. And since alpha is the lower bound of S by the definition of lower bound, then you get x greater than or equal to alpha for all x in S by the definition of lower bound. Yeah. So alpha satisfies condition A. And now I will show that it satisfies condition B. And then I will show that it is the unique one, I mean alpha. For this proof of this theorem, first I show that it is satisfy condition A, condition B. And then I show that alpha is the unique one. There is no two alpha. This is only one. You understand? The process of my proving is like this. First, I show that alpha satisfy condition A and condition B. And then I will show that there is only one alpha. Okay. And now I show that it's satisfy condition A already. And now I mean that then I will show that alpha satisfy condition B. Okay. Okay, let's start. For any number bigger than what? Bigger than alpha. It can be written in the form alpha plus epsilon, where epsilon is positive. I mean alpha is greater than 0. Positive. Yeah. Yeah, exactly. This is true. Any number that is bigger than alpha, it can be right in the form alpha plus epsilon, where epsilon is the greater one. I mean the greater than 0, right? Alpha is greater than 0. So any number that is bigger than alpha can be written in the form alpha plus epsilon. Okay. Let me omit this one. I need to specify or to prove. Yes. Okay. So I repeat this one again. For any number bigger than alpha, it can be written in the form alpha plus epsilon, where epsilon is greater than 0. Let me call that number, call it, yeah, call it B. So B equal to alpha plus epsilon, right? And from this, since B equal to alpha plus epsilon, B, yeah, B is not a lower bound of S. Why? You can think this. You can think this. Why I get that B is not a lower bound of S when B equal to alpha plus epsilon? Remind you that. Please think about the definition of infimum of a set, right? Yeah. Infimum of a set is what? Is the lower bound that is the biggest one. I mean that to find the infimum of a set, you have to find all lower bound, and then you choose the biggest one. It become what? The biggest one, it become the infimum of a set. And from this, because of alpha is what? Is the infimum of the set S. So alpha is the lower bound that is the biggest one. Among the lower bound of S, no one is bigger than alpha. And now B is bigger than alpha. So it's not a lower bound of S, right? Yeah. Okay. And since B is not it's not an upper bound of S, then you get this one. Then there exists x0 in S such that x0 less than B. X0 less than B. Why? Why you get like this? Remind you one thing, you will understand. What is the definition of lower bound? Alpha is a lower bound of S. Lower bound of S if what? X bigger than or equal to alpha for all X in S. This is the definition of lower bound, right? And if you change alpha is not, let me recall you again. Alpha is a lower bound of S. If X is greater than alpha for all X, for all X in what? In S. Like this. This is the definition of lower bound. And now, we just reverse. Alpha is not. You can check. Alpha is not a lower bound of S. If there exists, right? This one for all like in S. There exists X 0 in S such that X0 less than alpha. for, yeah. So why do I get this? As I told you, we can say the reverse side of what? The definition of infimum of a set, definition of, definition of a lower bound of a set. When you say alpha is not a lower bound of S, if there exists x0 in S such that x0 less than alpha, right? And now I get there exists x0 in S such that x0 less than b, right? Because b is not what? It's not a lower bound of what? Of S. If you want b to be a lower bound of S, if and only if x greater than or equal to b for all x in S, right? For all x in S. And now b is not. B is not a lower bound. And then you get there exists x0 in S such that x0 less than b, right? Yeah. Okay, and from this, since b equal to what? B equal to alpha plus epsilon, then you get there exists, yeah, then there exists x0 in S such that, yeah, such that x0 less than b and b equal to alpha, yeah, plus epsilon, right? Plus epsilon. Moreover, if you want to choose the general epsilon, you can choose, yeah, choose epsilon equal to what? Equal to b minus alpha. Yeah. And since b is bigger than alpha, so b minus alpha is a positive one. Yeah, we can choose alpha like this in general. We still get it? Okay. And from this, so alpha, that is the infimum of a set S, satisfy what? Satisfy condition B. Yeah. Or property B. In general, we can choose epsilon equal to b minus alpha. Because b is greater or bigger than 1, alpha, so b minus alpha is a positive one. For b in general and alpha in general, so epsilon is any positive number in general also, right? And now we have found that alpha satisfies condition A, condition B. And now we have to show that there is only one alpha, or there is unique alpha that satisfies condition A and B, right? Yeah. Let me recall this theorem again. This theorem, we call it theorem 1.8. It talk about, or it say like this. If a set of real number S bounded below, then the infimum of S is the unique real number alpha, the unique real number alpha that satisfies the following condition: A, x greater than or equal to alpha for all x in S. B, if epsilon is greater than 0, then there exists x0 in S such that x0 less than what? X0 less than alpha plus epsilon. And now we have shown that alpha, that is the infimum of what? Set S, satisfy condition A and B. And now we have to show that alpha is unique. And to show that alpha is unique, I will use the contradiction technique to show this. Okay? Yeah, show that alpha is unique by contradiction. Contradiction. Suppose that we have two alpha. Suppose that we have two alpha. We call it, we have two alpha. Yeah, we have two alpha. Call it alpha 1, alpha 2. With alpha 1 less than alpha 2. And remind you that we call alpha is the infimum of the set S. So alpha 1 is also the infimum of the set S, and alpha 2 also. I mean that I suppose I have two infimum of what? Two infimum of set S. Call it alpha 1, alpha 2. So let me call you alpha 1, alpha 2. It means like this. The infimum of S. Yeah. And now I want to show that alpha is only one, and by using contradiction, I suppose we have two alpha. I mean, I call it alpha 1, alpha 2 here. That is, or that are the that are the infimum of set A. Okay, and I will show that this is contradiction. This is contradiction. This will contradict it to something that is a fact. Okay? Yeah. Suppose that we have two alpha 1, alpha 2. Yeah. Then from this, yeah, let epsilon equal to alpha 2 minus alpha 1. And exactly alpha 1 is less than alpha 2, so epsilon is greater than 0. Yeah, and now we choose epsilon to be like this. And from the condition B, you remember condition B? If epsilon is a positive number, then there exists x0 in S such that x0 less than the infimum plus epsilon. I call it in that condition alpha plus epsilon. Yeah, condition B of the theorem. We have shown already that the supremum alpha satisfies condition B. X0 less than alpha plus epsilon, right? Where alpha is the infimum of what? Of the set A. And now alpha 1 and alpha 2 are the infimum of what? Of S. So alpha 1, alpha 2 must be satisfy condition B also, right? And from this, I just choose or just let epsilon equal to alpha 2 minus alpha 1. And by the condition that I choose, alpha 1 less than alpha 2, so I get epsilon greater than 0. And since alpha 1 is the infimum, yeah, infimum of what? Of S. Then by condition B, right? Condition B, there exists x0 in S such that x0 less than what? Yeah. Alpha 1 plus epsilon. Yeah. And this one equal to alpha 1 plus what? Epsilon equal to alpha 2 minus alpha 1. Alpha 2, yeah, minus alpha 1. Yeah, I just replace epsilon here by alpha 2 minus alpha 1. And this equal to what? Cancel alpha 1, alpha 2. So this one, you get alpha 2. Then you get x0 less than alpha 2. And this contracted. Why? And this contracted. Yeah. Contracted 2. Alpha 2 is the infimum of S. Why contracted? You remember? Alpha 2 is the infimum of what? Of S. And then alpha 2 is also a lower bound of S. And if alpha 2 is a lower bound of S, I mean that for all x in S must be what? Must be greater than or equal to alpha 2. And here we got x0 less than alpha 2. Yeah, this one. That's why it's contracted to alpha is the infimum of S. And if this is contracted to something that we suppose is what? Is wrong. I mean that at the end we get this contracted to something that is the fact, that is the first one. So our supposition or our supposing is not true. And what is our supposing? We're supposing that there are two alpha, we call it alpha 1, alpha 2, that are the infimum of set S. And now, something that we suppose is not true, it means that there is only one alpha, right?